Hi there. Welcome to our final session in our Inclusive Practices in Mathematics series. This is for kindergarten to grade 5 teachers, and today we're focusing on open questions. My name is Janice Nowakowski, and I'm a district teacher consultant for K-12 Mathematics and Numeracy in the Richmond School District. We've been talking a lot about inclusive practices in mathematics in particular during this series, and some of the things just, to go over again. We're building on students' funds of knowledge and interest. That's part of creating an inclusive space in our classrooms. We're nurturing belonging and community for all of our students. We're thinking of ways to present and represent mathematical thinking in different ways and through different means when teaching. We're creating choices for where and with whom students learn. We're creating choices in the materials, the tasks, the range of numbers students use, and the different access students have to tools and technology to represent and support their thinking. And then again, we're creating choices for students to represent their learning and their thinking in different ways. When we think about universal design for learning, there's 3 core ideas that we accept that there's going to be variability in our classrooms. We know that there's going to be a range of learners that have different needs and different interests, and we accept that. We expect that, and so we design for that. Saying that, we do have a firm goal for the whole class. We have like a meta goal that we're all working towards, a learning goal, and often a language goal to go alongside that. And then students might have their own individual or small group goals as well. It's the same intention and purpose for all students, but how students reach that goal and their goals is flexible in how they do that. And then we also, in UDL, really think about learner agency. So how we're moving biases and barriers for students and creating opportunities for students to make choices and advocate for themselves. Particularly in mathematics, and this work is from Katie Novak and Ashley Marlowe, we're thinking about participation and multiple means of engagement. So when we're doing a number talk or when we're doing counting collections, how are we creating opportunities for all students to engage with those mathematical experiences, those multiple means of representation, and then multiple means of action and expression as well. Some of the resources that we've drawn upon for this series are Rachel Lambert's new book on rethinking disability in mathematics, and then Katie Novak and Ashley Marlowe's book on universal design for learning in mathematics instruction, specifically for K-5. And there's a middle school one coming out soon. And then in thinking about students' funds of knowledge and being culturally responsive in our practices and in our assessment, we're drawing upon culturally responsive pedagogies from 2 of the books there on the slide on the right side. So in designing for math learning, again, it's engagement, access, choice, and one of the ways that we can do that is through open questions and structures. And that's what today's session is going to focus on. So why open questions in math? Why is it an important part of mathematical learning and thinking? It provides access points for all students. So consider those IEP goals you have for students and the access points that you need to provide for those students that have IEPs. Open questions are naturally differentiated. They have, they're often called low floor, high ceiling for a range. They have that range built into them. They provide challenge and complexity. So they have a higher DOK. DOK is depth of knowledge, and it's what many of the assessments in our province are based around. So that sort of surface level to that more deeper level type of application and thinking. So that challenge and complexity often is part of those open questions. Open questions build vocabulary, language, and communication. They create opportunities for collaboration, whether it's on the carpet or whether it's around a chart paper on a table, or whether it's on a vertical non-permanent surface like a whiteboard or a window or a white book page that you've pinned up onto the wall, and 2 or 3 students are standing around it working on a problem together, an open question. It's an opportunity for formative assessment. When you give open questions, you're looking at a lot of the curricular competencies. So there's multiple strategies, different ways to communicate our thinking, different ways to represent our thinking. And it also gives you insight in whether students actually really understand the concepts or not when you provide open questions. And then, of course, open questions can be contextualized. So they can be contextualized to connect to the students' identities and interests in your classroom. So what is open? When we talk about an open question, what part of it is open? Sometimes it's the materials, that students have a choice of materials. And maybe sometimes it's not even just the teacher that's making that choice. It's like, choose whatever material you like, not just what I've put out as the teacher, to help you think about this particular question. It might be the process that's open. So the solution, there might be the same answer that everyone gets to, but the process that different students take up may be different. So there's different strategies or different approaches, and that part is the open part. The solution might be open, where there's not just one answer, there's multiple possibilities, there's multiple answers, or in the case of a numeracy task, which is definitely an open question, there's different ways that students can respond as long as they can justify their solution. And then the inquiry itself could be open. So if you're doing an inquiry question, what do you know about fractions? What can you find out about fractions? What is the connection between this and that? Those sort of inquiry-based questions that are more of an investigation, those in themselves are open. So that's the openness of what is an open question. So an open-ended task, question, or problem means that one, either there are many different answers or solutions, or there are many different ways to get the answer or solution. And that would be what is typically, when you read the mathematics education literature, that is how an open-ended question or task is defined. So you see on the right-hand side, these are examples of, they both have the same answers. It's represent 1/2, represent 1/3. If 250 is the question or is the answer, what could the question be? But how students represent and get to those answers or solutions are all different. And that's the open part in those particular examples. Robert Kaplinski has named something, a little bit differently. He's called them open middle. So those questions where there is a solution, but you can get to them in different ways. He calls those open middle, that it's that middle part or the process that is open. And he has a whole website called openmiddle.com with a range of different tasks for students from, kindergarten through secondary, through grade 12. So there's different topics. They're all based around using the digits from 0 to 9. Sometimes they're just 1 to 9, and there might be an answer, like in this example, use the digits 1 to 9, at most 1 times each. Place a digit in each box to make the smallest or the largest sum. And so I've done this during math workshop a lot. I'll print out those little mats, as you can see in the photograph on the right. I've used little wooden tiles and put number stickers on them, but on Robert's website, he has a printable with the digits that you can print out on cardstock and cut up. And one of the things I really like about these open middle tasks is that students take their little 1 to 9 digits and they can move them around. So it's not like a whiteboard. It's not even like pencil and paper. They actually have like this kinesthetic material, and there's, it's less risky for them because they can just move them around and try them in different ways. Often for a question like this, where we're trying to get the smallest sum or the largest sum, I'll put a little whiteboard on the table or position the table near a whiteboard, and we can keep a little chart, and the students put their initials and the sum that they get. And we sort of see at the end who had the smallest sum or who had the largest sum or who had closest to 237, whatever the particular task is. But again, you can go to the website and find a huge range of tasks for these open middle sort of processes. And again, this is one of those ones that really does provide that challenge and complexity for some of our students. Here's some examples of structures for, sort of once you get some frames that you use over and over again, you can see how they can be used across different math content areas. So think about a hexagon and a rectangle. How are they the same? How are they different? So that same but different frame makes it open-ended, because there's not, there's some things that are the same about them and different that everyone can agree on, but students may see some other things. You could do that with a number. How is 1/2 and 3/4 the same, and how are they different? With numbers to 10 or numbers to 100, whatever, concepts you're working with. If the answer is 200, what could the question be? If the answer is 5, what could the question be? If the answer is 4 and 35 100ths, what could the question be? So thinking about different numbers across the grades. In some classes, if we were working on subtraction or working on multiplication, I ask them specifically to think about those kinds of questions that they add to the chart or the whiteboard, whatever it is. Other times you can just leave it even more open and see what students do with that. What different ways can you represent? There's a super open question, right? So what different ways can you make a hexagon? What different ways can you represent 3/4? What different ways can you represent 242? And thinking about place value and decomposing numbers in different ways. This one here, again, open in terms of there's some correct answers for sure, but some students may get all of them, and that's that challenge on complexity for them in terms of combinations, and others might just get one way. And so again, it's open enough that sort of phrasing of how many of each could there be. If a student gets one way, that might be a success for them. So there are 8 cupcakes, and some are vanilla and some are chocolate. How many of each could there be? Well, there'll be some students that figure out all the possible combinations, and that's extending their thinking. And then there's others who are like, oh, well, 4 and 4. That's, that's a possibility, and absolutely. So those, again, that kind of phrasing. And then, questions like this: what in the classroom is longer than a meter? What in the classroom is about 10 centimeters wide? What in the classroom has an angle of, 90 degrees? So again, where can you find things in the world connected to what you're doing? And again, there's not one correct answer. There's many possibilities. Some students might find 10 things. Some students might find one. And again, that is, moving their learning forward where they need to be practicing and learning. So again, some of those structures and those questions you use over and over and over again across the year, and you just make them part of your repertoire when you're designing questions for students. These are from Marion Small, and some suggestions around using, oh, sorry, I'm just noticing a message in the chat, which I will come back to afterwards. Dr. Marion Small is one of the most published mathematics educators in North America. She's Canadian, and these are just some of the questions that she often uses. So she suggests using soft words, and you saw that in that question about cupcakes. What could the combinations be, or what could possibilities be? So you divide number A by number B. The answer is a little more than number B. What could the numbers have been? Well, I mean, that's really, that's great problem solving and great amount of mathematical thinking happening there. So, and again, all sorts of possibilities. And students can use numbers that they're comfortable with, like hundreds and tens or 25s or 50s, or they could start to use decimal numbers or, more irregular numbers, not those benchmark numbers. So again, students can play with numbers within their number range. You add 2 decimal numbers and they're slightly less than 7. You add 2 numbers and they're slightly less than 20. What could they be? What might they be? So those soft words again, and you can see some more examples there on the screen. So some sources for open questions. The bottom left there are those open question books by Dr. Marion Small, who I was just referencing. These are the WNCP editions. So WNCP stands for Western and Northern Canadian protocols, and they were our 1995 curriculum, which carried over into 2006, and they're available through Rubicon Publishing. They have K1, 2, 3, 4, 5, 6, 6, 7, 8, or 7, 8, 9. I can't remember the grade combinations. And then they have a booklet. One's for number, one's for pattern and algebra, one's for geometry and measurement. So they align with our big ideas. And they're just full of open questions. She's divided them into some for the beginning of the lesson, some for the middle part of the lesson, and some for the consolidation or closure of the lesson. At the top left here, you'll also find open questions as the elaborations for the big ideas in our BC curriculum. And so you have your meta big idea, and then you have a list of these questions. How are division and multiplication connected or related? How are addition and subtraction related or connected? Where can you see fractions in the world around you? Those are sample inquiry questions, like I said earlier, are naturally open. On the top right-hand side, you see the practice questions on Learn 38. So if you go into our Learn 38 and you go into mathematics and numeracy, and you go into your grade level framework like K to 2, 3 to 5, or 6 and 7, if you go to the bottom, there's a little icon that looks like this. It says Math Concepts and Practice Questions. And then you've got pages and pages of practice questions that you can either print out onto cards, or you can project onto the screen, or you can read out to your class. And many of them are these open type questions. Peter Lilydale has a set of open questions and numeracy questions on his website. There's his website there. And then these two books, which are in many of your enrichment schools libraries, are good questions for math teaching. Why ask them and what to ask? And again, there's a K-5 book and then a 6-9 book. And they're divided by the big ideas, numbers, number operations, patterns in algebra, geometry, data, etc. And again, are just full of these open questions. The second edition have new covers. Those are the first edition covers, those light purple and dark purple ones. So in thinking about our open questions, we also can think about the open structures that we're using in our class to design for access to students to math learning. So we've talked a lot about Math Workshop, and there's a whole video, a burst video about Math Workshop. And in Math Workshop, we have, the choice of tasks, the choice of materials, the choice of number ranges. That's, again, what makes many of those tasks open. Themselves are open. Again, we have many videos about what is numeracy, what are numeracy tasks, where can you find them. But a numeracy task is sort of an extension to problem solving and an application of mathematics. And there's many possible answers in many ways that students could come up with a solution. Investigations or inquiry projects, again, often in the studio, a class will come and we're investigating fractions. I'll do a mini lesson on the carpet, and then it's up to them to continue to investigate that idea, whether it's comparing fractions or equivalent fractions or representing fractions in different ways and making the choice of how they're going to investigate that through different materials. Something that I use all the time is having students create their own games or their own practice task connected to whatever learning goal you're working on as a class. And in that design of their own game or their own practice task is very revealing to you as the educator, the teacher, what they know and what they still need some more practice with. Problem posing is a high-level extension of mathematics understanding. So that opportunity not just to solve problems, but to pose their own problems for either themselves to solve or their classmates to solve. And connected to that is math storytelling. So giving students opportunities to play with a mathematical idea, whether it's combining amounts, separating amounts, thinking again about measuring or thinking about multiplying in groups of, that can all be played out. Those actions of the mathematics can be played out through math storytelling with materials and characters. So again, the video from this and the slides from this session, as well as other supporting resources, will be added to the Inclusive Practices tile on RichNet on Learn38, and that's where you can find it. You can see there's also the Math Workshop tile there with other resources, math games, those practice questions, etc. So as we finish up this burst series and this particular burst session, I'd like you to consider what different ways can you open up questions and learning experiences for your students? How do open questions and structures provide opportunities for all students to access foundational math content and competencies? And in what ways do open questions and structures provide insight and opportunities to learn more about what students know and can do? And I just think for me, it's that challenge and complexity and access that allows me to circulate. Students are engaged with these open questions and tasks, and I can circulate and listen in and observe and really get a sense of what students know and what they can do. So really ideal for formative assessment. So thank you for joining us for this last burst session for K-5 and the last one of the Inclusive Practices series. It has been my pleasure hosting these this year.